Welcome to clickmyproject.com. Now we discuss about the title Improving Saliency Detection via Multiple Kernel Boosting and Adaptive Fusion. Now we discuss the abstract for the process. This paper processes a novel framework to improve the saliency detection performance of an existing saliency model, which is used to generate the initial saliency map. First, a novel regional descriptor consisting of regional self-information, regional variance, and also the regional contrast on the number of features with local, global, and border context is proposed to describe the segmentation region at multiple scales. Then, regarding the saliency map computation, as a regression problem, a multiple kernel boosting method based on support vector regression, that is known as MKB SVR, is proposed to generate the complementary saliency map. Finally, an adaptive fusion method via learning, a quality predictive method for saliency map, is produced to effectively use of the initial saliency map with the complementary saliency map and obtain the final saliency map with the improved on saliency detection performance. As a result, on two public datasets with the state-of-art saliency model, we have to propose and considerably improve the saliency detection performance with the various saliency model. Now we discuss the flow diagram for the process. This is the overall flow diagram for the whole process. In that you can see the input image module. In the input image you can take the input image from the dataset. Dataset is the folder which is the collection of several images which is undergone for the process. After getting the input image from the dataset, the pre-processing is carried out. In this process, we have majorly considered the two pre-processing steps. The first one is the image resizing, and the second pre-processing step is image filtering. In the image resizing, we have to reduce the dimension of the image as a constant size. In the filtering step, we have to filter the noise in the image using the Gaussian filter method. After the pre-processing completion, the initial saliency map generation is carried out. For the initial saliency map generation, we have to consider the three types of algorithms. The first one is the LBP. The LBP is abbreviated as a local binary pattern. Then the algorithm shift is used to take an feature from the image, and also the HOG is an algorithm to take the feature from the image. After gathering the feature points from the saliency, then the complementary saliency detection is carried out. In the complementary saliency detection, we have to consider the multiple kernel boosting on support vector regression is undergone for the complementary saliency map. Then combined with the initial and the final complementary saliency map along with the SVM is carried out. So the three type of SVM, initial and the complementary, combined together to form an final saliency map. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory as the file you have contained, and you can see the main.m file. Right click in that file and click the button run. Now the initial GUI window was opened. In that you can see the several buttons and the several options. In the top of the GUI window you can see the file and open the input image. Now select the any one image from the dataset and click the button open. After clicking the button open, the input image which I was selected is displayed in the axis 1 with the title input image. Now click the button pre-processing. After clicking the button pre-processing, these two pre-processing steps are enabled. First click the image resize option. Now the resized image is shown in the axis 1 with the title resized image. After getting the resized image, click the button image filtering. After applying the filtering, the filtered image is displayed in the axis 1 with the title filtered image. Now click the button initial saliency map. Now the color transformation and the features are enabled. Now select the any one color transformation from the option. Now the HSV color transformation is applied and the corresponding HSV images is shown in the axis 1 with the title HSV image. Then click the second option, that is the lab color transformation. Now the lab image is shown in the figures, that is the figure 4 shows the original grayscale image and the figure 5 and figure 6 shows the labeled image. Now click the button LBP. After applying the button LBP, the features are saved in an corresponding mat files and the respected image is shown in the axis 1. Then the shift feature is extracted for the images. Then the HOG features are also gathered from the images. Now click the button complementary saliency features. Now the complementary image is shown in the axis 2. Then click the final saliency map. Now the final saliency map is shown in the axis 2.